Okay, so this video is looking at Cartesian vectors, and specifically Cartesian unit vectors. You've already met three unit vectors. You'll be familiar with the unit vector I, J, and K. And what we can do is we can now talk about a vector A, which is in all three directions, and it can have a unit vector associated with it. That unit vector will tell you the direction, but it won't tell you the units. It won't have a magnitude greater than 1, so it's a proportion of how much the vector is going in all three dimensions. So the unit vector of A will be defined as the Cartesian vector A divided by its magnitude. We can simplify that a bit, so we can say if the vector A is AX in the I direction, AY in the J direction, that should be Y, sorry, and AZ in the K direction, then the magnitude of that using Pythagoras will be that. And we can then go on to find our unit vector as so we've defined our unit vector if we were given some dimensions. However, we can also define it if we're given some angles, specifically angles straight from vector A to the x, y and z axis, and I'll just show you quickly what I mean. Sorry, my wires aren't looking very good today. So it might be given an angle between vector A and the x-axis, and we call that our alpha angle, between vector A and the y-axis, we call that our beta angle, between vector A and the z-axis, and we call that gamma. And we can say that cos alpha equals AX over A, how much in the x direction divided by the overall magnitude. And similarly, we can define cos beta as being AY over A, cos gamma as being AZ over A. And then knowing these three facts, we can then substitute those back into our definition of a unit vector. So we can say, well, our unit vector we've very simply described as cos alpha I plus cos beta j plus cos gamma k. So that's a very brief introduction to unit vectors. So a unit vector describes the direction of a vector but has no magnitude or any units associated with it. Why you'd want to use those becomes more obvious when we're looking at things like forces acting along a line that's not the main line of action of the force, or when we look at moments in a future lecture. But that's a very brief introduction to unit vectors from lecture 2. The next video will show some examples of how to use that.